Alright, as we continue our discussion on orbitals and probably electron configuration, I want to give you a couple of caution as we do this. Okay, you saw me drawing those circles around a core and shading it, and it's all great. Now those type of circular notations, we can only do it for so many elements unless you become so expert for a point where maybe you can do it. But most of us, I'm excluding myself from that list. Most of us, it will get confusing once you get to maybe the third row elements on the periodic table. Okay, we however are going to learn it for maybe the first few elements, and then take that knowledge that we learn from it to extend it to write actual electronic configurations, because that's how chemistry is universally represented. Say you go to Germany or France and you have a conference and you talk about electronic configuration, well, that is a universal language that everybody would understand. Perhaps not everybody has learned it in that circular fashion, or maybe you don't need to explain it as much, just give the configuration, everybody's got it. Okay, so we will learn electronic configuration. Okay, so because of the cumbersomeness nature of that particular structural arrangement, it just may become confusing. But we will use that with the earlier elements just to understand the concept better. Okay, with that said, before we go further, okay, I did talk to you about, let me get my red color. Okay. Okay, you are now familiar with, while you may not be entirely comfortable with the idea of everything that's happened. Okay, we did however learned the idea of orbitals. Okay, and we learned that there are 4 types of orbitals. Now let's say if you're in a 400 or 500 level inorganic chemistry class, I would go into much more details on the nature of these orbitals and stuff like that. Okay, but we're in a Chem 150 class. Okay, so we do need to know the fundamentals, but we don't need to go too far into it. Okay, I'm going to create another column called max number of electrons. Okay, there's a reason for it, and I'm probably going to put a divider here. The s orbital, okay, the s orbital can hold a maximum of 2 electrons. Okay, the p orbital can hold a maximum of 6 electrons. D orbital can hold a maximum of, sorry, let me erase it. Hold a maximum of 10 electrons, just the orbital. Okay, and the f orbital can hold a maximum of 14 electrons. You just have to remember that each of them are separated by 4. Between 2 and 6 there's 4, 6 and 10 there's 4, 10 and 14 there is 4 as well. Okay, now this is very important. The reason I'm doing this is, when I watch videos on YouTube, people are explaining what I'm going to explain next in a really complicated way by doing some accounting. I mean, we're chemistry where we don't want to do accounting. Okay, there's enough math already to worry about, not to do accounting like accruing, and they use complicated terms. I almost think I'm not watching a chemistry video. So I'm going to explain it the way I learned it myself, and I've taught countless students over the years. This is why we're not going to do any accounting. Okay, we're going to learn chemistry strictly with a little bit of math, and that's it. Okay, all right.